Today, I want to talk about the Mosfet transistor. If you add up all the transistors in the world, there are far more Mosfets than bipolar or any other kind of transistors. The Mosfet is the workhorse of the electronics industry. And it'll probably be that way for the near future, for the next 10, 20 years, or perhaps even beyond. So it is very important to understand the Mosfet transistor. So this funny name, Mosfet, stands for metal oxide semiconductor field effect transistor. So let's understand a little bit about what that means. So let's understand the MOS part, the MOS part. And that refers to how the transistor is constructed. In the old days, there was a gate that was made of metal material. So the M in MOSFET is for metal. And this metal forms what is called the gate terminal. Now next is the word oxide, and underneath this gate is an oxide. Which chemically is silicon dioxide, which is also just plain glass. So this oxide is an insulating material. Now below the oxide is the semiconductor. And that is composed of a diffusion and a diffusion region in a wafer. This is the surface of the wafer. This is the thickness of the wafer. And let's presume that this is N-type dopant. This is an N-type dopant. And our starting wafer is P-type silicon. So this silicon region is the semiconductor. And thus, the MOS refers to the metal gate, the oxide under the metal, and the silicon semiconductor material under that. So what does the FET part stand for? Field effect transistor. If you put a positive charge on this gate relative to these N-type and P-type semiconductors, you form an electric field. And in the case of N-type material with a P-type wafer, this electric field will attract electrons to the surface. And this region under the metal gate is called the channel. Now I should point out that the metal gate is not used anymore. The modern gate is made of silicon. But the name stuck, so people didn't want to change the name MOSFET to something different. So the field effect transistor means that when you apply a voltage to the gate, you get a field. And this field affects the silicon below and forms a channel. Thus, field effect transistor. Now, if I draw the symbol for this transistor, let me change colors here. This is the basic symbol. Let me change colors here. And let me shade the N region a little bit here. Let me reduce the size of this. So this is N-type silicon. This is N-type silicon. This can be called the source. This can be called the drain. Now the symbol, this would be the source terminal. This would be the drain terminal. And this region here is the gate material, which is this gate connection. So what happens, you can think of this symbol as the gate voltage is increased. You get an electric field in this insulating glass region. And that electric field forms a channel between the source and the drain. There are two basic types of Mosfet transistors. We have the N-channel, which is also called an Nmos transistor, and we have the P-channel transistor, which is also called Pmos. So let's investigate the structure of the N-channel and the P-channel. So if I have the surface of a silicon wafer, where this is the thickness of the wafer, and I diffuse in a very deep N region, which is called an N well. And let's say that the wafer is P-type material. Now this N well is going to hold the P-channel or the PMOS transistor, and the P-type wafer will hold the N-channel or the NMOS transistor. So let's create the NMOS transistor. I'm going to put in an N-type diffusion, another N-type diffusion, and construct a gate electrode. Now the PMOS transistor has a similar structure. It has a diffusion, but this diffusion is a different type of material from the NMOS transistor. There's a gate like the NMOS. And there's also another diffusion that will go here, and this diffusion will connect to the well. There will be a diffusion out here that connects to the substrate. So let me color code these diffusion regions. I'm going to use the green color to denote an N-type material. So this will be the NMOS. So this would be an N-type. This would be an N-type. And when these N-types are fabricated, there's an N-type that's put in the N well. And this is going to be a very low resistance region to contact the end well. So the contacts will all be done at the surface of the wafer. Now let's show where the P diffusion regions are. This is a P diffusion, and it makes a lower resistance contact to the P substrate. So this substrate is all P material. And the PMOS diffusion regions are, of course, a P material. Now the N well, as the name implies, is an N-type material. So let's add some names to these terminals. And let me change the brush. This would be called the gate terminal. This N region, this N region are the source and drain. And they're interchangeable. The structure is the same. I'll call this the source, and this diffusion the drain. This is a contact to the p-type substrate. This is a contact region to the N-well. This is a p-type material, p-type material. This is the gate. And this p-type material forms the source drains. So I'll call this the source and this the drain region. And now let's draw the symbols for these transistors. So here I have the Nmos symbol. This is a gate, source, drain. And there's actually a fourth terminal. And this fourth terminal is the substrate connection. I'll call it SUB. And that's this connection here, SUB. And that connects to the p-type silicon material. Now let's draw the symbol for the PMOS transistor. And I draw a little circle in the gate region to distinguish this transistor from the NMOS. So this is the gate material, this is the source, this is the drain. And there is a fourth connection, which is the N-well connection. So that is this region that holds the PMOS transistor. In a future video, we'll go into more detail and we'll explain the detailed operation of the Nmos and Pmos transistor. Or any other kind of transistors. The MOSFET is the workhorse of the electronics industry. And it'll probably be that way for the near future, for the next 10, 20 years, or perhaps even beyond. So it is very important to understand the MOS. So let's understand the MOS part, the MOS part. And that refers to how the transistor is constructed. In the old days, there was a gate that was made of metal material. So today, I want to talk about the Mosfet transistor. If you add up all the transistors in the world, there are far more MOSFETs than bipolar Mosfet transistor. So this funny name, MOSFET, stands for metal oxide semiconductor field effect transistor. So let's understand a little bit about what that means. The M in MOSFET is for metal. And this metal forms what is called the gate terminal.